half-life. Now, before we do this, I do want to tell you, you've probably learned about half-life in your math class. What I'm going to tell you is the half-lives I do in this class are going to be much, much, much simpler. We are dealing with whole number half-lives, so you're not going to have any decimal half-lives. And on top of that, I'm probably not going to give you more than 6 half-lives. So I'm not even going to give you an equation here. I'm just going to have you conceptually walk through it. Now, this is how radioactive elements decompose, and it's actually decay, I should say, decay, how they decay, and it's actually really kind of unique that they decay at a rate that depends on how much is present, in such a way that every half-life, half of the substance is decayed away, decays into a new, more stable isotope. Then at the same amount of time later, half of what was left is now decayed. So a different amount, it's actually decaying at a different rate depending on how much is present. It's kind of interesting, okay? I want you to think about this with me real quickly. We got to think about some fractions, okay? If a half-life were 5 minutes, okay? If a half-life was 5 minutes, after 5 minutes, what fraction would be left? Half. Okay? If another 5 minutes passed, half of half would be left. So what fraction of the original would be 1/4? If another 5 minutes passed, at that point we would have 1/8. And then if another 5 minutes passed, at that point we would have 1/16. So every time a half-life occurs, we're getting rid of half of what was there before. What's 1/2 of 1/4 is 1/8. So do keep that in mind as we go. Now, I told you that we weren't going to use a formula for this, but sometimes students just want to have a formula to plug and chug. If you have a formula that you used in math class that you really desperately want to use again, use it. I'm not going to show you any examples because I have not taken math class since 2009, and I don't even remember what formulas you used. If you desperately want to use your formulas, I am going to tell you, you're not going to have to deal with any sort of logs or exponents here. You're just conceptually thinking through it. If you can divide by 2, you can do these problems. You do have to understand what a half-life is though. But I'm going to give you a hint here. To solve these problems, I want you to first find the number of half-lives. On almost every problem, that's going to be your first step to figure out exactly how many half-lives have occurred. And then from there, this number of half-lives is the number of times you have to divide by 2. So let's just jump right in. Here's the first problem. The half-life of polonium-210 is 138.4 days. So our half-life is 138.4 days. Okay, how many milligrams of polonium-210 remain after 415 days? So there's our total time. In total, we've had 415.2 days. I told you the first step is to always find the number of half-lives. If one half-life is 138.4 days, but we've had a total of 415.2 days, how do we figure out the time, the number of half-lives that have occurred? We divide those. We divide those. If the total is 415.2 days, and each half-life is 138.4 days, we divide them. We should get a whole number. If you don't get a whole number, you've done something wrong in this class, because I'm always going to give you whole number half-lives. And when we divide those, yay, we get 3. What does that mean? It means you need to divide in half 3 times, okay? So here's what I want you to do. I want you to kind of create a table, okay? On one side, we're going to say number of half-lives, and on the other, we're going to put the mass that remains. Okay, so when we start with 2.0, and at that point, we've had no half-lives. We divide in half one time. We divide in half, now we have 1.0. Okay, we divide in half again, now we have 0.5. We divide in half one more time, and now we have 0.25. Each time, this means that you're going to divide in half 3 times. 1, 2, 3. Each time you're hitting your calculator, divided by 2, divided by 2, divided by 2. I do need to see your work in some form or fashion. I prefer it in this nice little table, but you could just list these 3 as well, showing me that you're dividing it in half 3 times. This would be your final answer, 0.25, and that is unit milligrams. Cool, let's do another one. Assuming a half-life is 1599 years, how many years will be needed for the decay of 15/16 of a given amount of radium-226? Okay, the first step is going to be to find the number of half-lives that have occurred. How many half-lives have we gone through? So one half-life is this. That's a half-life, just one. We need to figure out how many have occurred. If we've decayed 15/16, would you agree that what remains is 1/16? So we need to figure out how many half-lives that would be. Okay, we're going to fill out this chart again. Half-life versus amount. In this case, it's not a mass, but an amount. Okay. We start with 100%, okay? After one half-life, we have 1/2. After 2 half-lives, we have 1/4. After 3 half-lives, we have 1/8. And after 4 half-lives, we have 1/16. So that's what we need to define first. We've had 4 half-lives. Okay? 1 half-life is 1599 years. But we haven't had 1 half-life, we've had 4. So what do? Multiply by 4. So you're actually doing slightly different math each time. But if you know the concepts behind half-life, you're going to be able to do these problems. So it's 1599 is 1 half-life, but we've gone through 4 half-lives to get us to 1/16. So that's 1599 times 4, and that's 6396. 6396, and that would be years. There's our total time. Okay, let's do another problem. The half-life of polonium-318 is 3 minutes. If you start with 16 milligrams, how long will it be before only 1.0 milligrams will remain? So your first step is to find the number of half-lives. So we need to figure out how many half-lives have occurred, okay? So let's fill out our little chart. Number of half-lives versus mass, okay? When no half-lives have occurred, we're at 16 milligrams. That's our initial amount. When we've had 1 half-life, what do? Divide by 2. After 1 half-life, we have 8.0 grams. After 2, we have 4. Now we're going to keep doing this until we get to 1. After 3 half-lives, we have 2. We're dividing in half each time. After 4 half-lives, we have 1. So, first step is to find the number of half-lives. Number of half-lives is 4. We've gone through 4 half-lives. We've divided in half 4 times. So the half-life of polonium-310 is 3 minutes. If you start with 16 and end with 1, how long will it take? So how long will it take to get 4 half-lives if one half-life is 3 minutes? So 1 half-life is 3 minutes, but we've gone through 4. We're going to have to multiply here. 3.0 times 4 is 12 minutes. Now, my honors folks, you do have to follow sig figs on these. 2 sig figs, 2 sig figs, 2 sig figs. That's why we have 2 in our final answer. And I did that on our others as well. 2 sig figs, 4, 4. So our final answer needs to have 2. 4 sig figs. This is an exact. So we've got 4 sig figs in our final answer. So we are still following sig fig rules there. Okay, let's do another one. If it takes 63 hours for 20 milligrams to decay to 2.5, what is the half-life? So now we're trying to figure out exactly the time for half of the substance to decay away. So let's go ahead and do this one. The first step is to figure out how many half-lives have occurred. We're going to do something very similar up here. We're going to divide this number in half over and over and over again until we get to 2.5. Once we get to 2.5, we're going to be like, hey, there it is. So we're going to fill out this little table. Number of half-lives versus the mass. So when no half-lives have occurred, we have 20 grams. So that's our initial. When we have 1 half-life, we've divided in half 1 time. We're at 10. After 2 half-lives, we're at 5. I'm keeping with the 2 sig figs honors class. And then after 3 half-lives, we're at 2.5. Do you agree? That is where we're trying to get to. So first step is to find the number of half-lives. There have been 3 half-lives. We know it takes 63 hours to get through 3 half-lives. We're trying to figure out the time for 1 half-life. So we're going to take 63 hours, I'll move over here so you can see that, divided by 3. Why? This is the total time. And the total time consists of 3 half-lives. We're trying to figure out the time for 1 half-life. So you divide them. And when you divide those, you get 21 hours. And there is your answer. Honors folks, let me double check sig figs. 2, 2, 2. So there should be 2 in our final answer. So there you go. There's not really a set way to always do it. But the first step would be to figure out the half-lives. Do whatever you can to figure out how many half-lives have occurred. And that's the number of times you divide by 2. So it's kind of more of a matter of understanding what half-life is, and that's going to tell you how to solve the problem.